When you manage AKS clusters, you need to control who has access to your Kubernetes resources and services. Without proper authentication and authorization measures in place, accounts might gain unnecessary access, making it difficult for you to track who made changes. To secure access, you can integrate AKS with Microsoft Entra ID, Kubernetes RBAC, Azure RBAC, and enable pod managed identities for resource authentication. Let's discuss each of them in detail. Let's discuss AKS authentication with Microsoft Entra ID. The best practice for managing authentication in AKS is to integrate your cluster with Microsoft Entra ID. This will allow you to centrally manage user identities and ensure that any changes in user accounts or group memberships automatically reflect in AKS access controls. Instead of Kubernetes handling authentication separately, you rely on your enterprise-ready identity solution, which makes it easier to enforce security policies. With Microsoft Entra integrated clusters, you define roles and cluster roles to assign permissions to resources. You bind these roles to Microsoft Entra users or groups. This ensures access is always up to date. And enforce least privilege access, which prevents unauthorized changes. Bottom line, by linking AKS authentication to Microsoft Entra ID, you simplify identity management and ensure that access remains controlled across your Kubernetes cluster. To control access within your AKS cluster, you should use Kubernetes role-based access control. With Kubernetes RBAC, you can define granular permissions for different cluster resources. You can scope access at the namespace or cluster level and ensures users only interact with approved workloads. And you can use role bindings to assign permissions to users or groups authenticated via Microsoft Entra ID. For example, if a developer needs access to resources in a specific namespace, such as Finance app, you assign an RBAC role only for that namespace. This ensures they can only modify applications in their assigned environment while keeping the rest of the cluster secure. Bottom line, with Kubernetes RBAC, you enforce strict access control and prevent unauthorized users from making cluster-wide changes. When your Kubernetes workload needs to interact with other Azure resources, like Azure SQL Database, Blob Storage, or Cosmos DB, you should not store static credentials in pods. Hard-coded credentials in containers are a security risk, which makes them vulnerable to exposure or misuse. Instead, use pod managed identities to allow workloads to securely authenticate with Azure services without manually managing credentials. With pod managed identities, AKS dynamically assigns a Microsoft Entra identity to the pod, allowing it to request an access token from Microsoft Entra ID at runtime, use the token to authenticate with Azure resources, and avoid storing static credentials in container images or Kubernetes secrets. Beyond Kubernetes RBAC, you also need to manage access to the AKS cluster itself. This is where Azure role-based access control helps. In AKS, there are two levels of access you need to control. First one is access to the AKS resource in your Azure subscription. This determines who can scale, upgrade, or delete your cluster using Azure APIs. And the second is access to the Kubernetes API server. This defines who can interact with workloads inside the cluster, which can be managed with Kubernetes RBAC or Azure RBAC integration. Bottom line, by applying Azure RBAC, you ensure that only authorized users can manage the cluster infrastructure while keeping operational control in check. Let's unpack how pod managed identities work in AKS. AKS supports two modes for pod managed identities. One is standard mode and second one is a managed mode. Standard mode uses two components in the AKS cluster: Manage Identity Controller and Node Manage Identity. Manage Identity Controller assigns and removes identities dynamically. Node Manage Identity intercepts security token request and ensures only authorized pods receive the tokens. MIC grants and revokes identities as needed based on Kubernetes events. Manage mode removes the MIC component, which simplifies security. Manage mode pre-assigns identities to the virtual machine scale set used by AKS, and manage mode reduces permission requirements, which minimize the attack surface. Bottom line, with pod manage identities, you automate authentication for your workloads, keeping credentials secure while enabling seamless access to Azure resources. Let's discuss how user authentication works in AKS. When a developer interacts with an AKS cluster, the developer gets authenticated with Microsoft Entra ID. Microsoft Entra ID issues an access token. The developer uses the token to run a Kubernetes command, such as kubectl create pod. Kubernetes validates the token with Microsoft Entra ID and retrieves the user's group membership. Then, Kubernetes RBAC policies apply, which determines if the request is allowed. And if authorized, the requested action is executed successfully. Let's discuss now how pod authentication works in AKS. When a pod managed identity requests access to an Azure service, a pod requests an access token from Microsoft Entra ID. The node managed identity, which is an NMI server, intercepts the request and validates if the pod is authorized. If authorized, the NMI server retrieves the token from Microsoft Entra ID. The token is passed back to the pod and allowed to access the required Azure services securely. Bottom line, this authentication flow ensures that both users and application follow strict identity and access management rules in AKS. Overall, to keep your AKS cluster secure and compliant, you should use Microsoft Entra ID for centralized authentication management. Enforce Kubernetes RBAC to restrict user permissions within the cluster. Apply Azure RBAC to control access to AKS resources in your subscription. And use pod managed identities to enable secure workload authentication without exposing static credentials. By implementing these authentication strategies, you ensure that your AKS environment remains secure, manageable, and compliant with enterprise security standards.